Hello, in this video tutorial I will explain how to solve the focused questions that you have in your end of term exam. So first we'll start with the subtopic of classifying chemical equations. In this topic, you are responsible to predict the outcome of a synthesis, combustion, decomposition reactions, predict the outcomes of single replacement reactions, and predict if in a single displacement reaction a metal can replace hydrogen and or another metal in a solution. And finally, the last KPI, predict the outcome of a double displacement or replacement reaction. So I'll walk you through the questions. So let's first begin. What type of chemical reaction is represented by the particulate diagram? When you are given a particulate diagram, before you answer, compare the figures that you compare what's happening before the reactants and after the products. So here I have hydrogen, which is H2, 2H2, twice of these H2, added to oxygen, and it seems that these molecules are combining one gray from here and one white from here, which is the 2H2O. So we are talking about hydrogen plus oxygen giving 2H2O. So this is a combination reaction, or what we also call a synthesis. Next, the equation below is an example of A. When we look at this equation, we see that this compound is added to oxygen, and specifically the products are CO2 and H2O. When when in a reaction I have a substance added to H2O, and specifically we obtain CO2 and H2O, in this case we are talking about a combustion and not synthesis. This is a combustion reaction. So you have to confirm that the products are CO2 and H2O, and in the reactant you have O2, therefore it will be a combustion reaction. Next, what type of chemical reaction is represented by the equation below? So you have here A coupled with X and B coupled with Y. What's going on is that A is now coupled with Y and B X. So what we did here is a double replacement reaction. Always compare before and after to know the answer. Now, the use of reactivity series. In this case, in order to answer this question, which of the following reaction will occur, you need to go and to open in your exam and use the given reactivity series. So, here are the reactivity series. Before you start using those reactivity series, double check how they are arranged. Like for example here, the one on top are the most active elements, metals, and the one least are the lowest reactive metals. So let's take one by one question. We have potassium, K, and silver nitrate. So can potassium replace silver? So can potassium, let me just erase here, can potassium replaces silver? So when you look at this one, potassium is more reactive than silver. So the answer is yes, potassium can replace silver. So this reaction, it will occur. Next, can copper replace calcium? Can copper replace calcium? Here is the copper. I'm going to erase again. Here's the copper and here is the calcium. Obviously, the copper is below calcium, so copper is less reactive than calcium, and copper cannot replace calcium. Zinc and Na, sodium, zinc and sodium. Here's the zinc and here's the sodium. So the metal to replace another one, that other one has to be written below that metal. So here zinc is below sodium. Zinc is less reactive than sodium. Zinc cannot replace sodium. In order to replace, the metal that will replace has to be above. So here's potassium and here's silver. Potassium can replace, but zinc cannot replace sodium. So here cannot replace. Same thing for iron and barium. Iron, I'm gonna erase so that you can see it properly. Iron, there's here's the iron, and here's the barium. Where's the barium? There is no barium on this table, but obviously that we were able to identify that potassium can replace silver in the first one. Now let's move on with the questions. Use the information about reactions P, Q, and R in the given table to answer the questions. The single replacement reaction is R. A single replacement reaction is when I have an element that will replace a metal in a compound. So here is a compound and I have a single metal that we are planning to check if it can replace copper. Obviously zinc took the place of copper with sulfate and now copper is alone. So this is the single replacement reaction. Whereas the first one, this molecule is divided into two. So here I have a decomposition reaction, and this one, a substance added to O2, and particularly I have the product CO2 and H2O, then this one is definitely a combustion. So the replacement, the single replacement is just R, and the decomposition is Q. Here's the answer, Q. Now, moving on, we need to use the reactivity series to predict whether each of the following reactions will occur or not. If a reaction will occur, we will write R. If the reaction will not occur, you will write NR. So here again, you need to look at the reactivity series. So, and in the reactivity series, sometimes they give you also non-metals to look at. So in this one, here I have the question of one second, I'm just trying to open one table because here I have Cl and Br. These are non-metals, so I need to check if chlorine is more reactive than bromine. So here in this one, here's the non-metal. I'm trying to get you a table where I can see the non-metals as well. So according to the reactivity series, the one that is given here in the formula sheet does not contain reactivity series of non-metal. But if this comes in the exam, then definitely there will be next to it a small table, just like the one I showed you in class, a small table giving the reactivity of non-metals. And the reactivity of non-metals usually here, the most reactive to the least reactive, and it comes in this order: fluorine, chlorine, bromine, and iodine. So can Cl replace Br in that question? Can Cl replace Br? Cl is more reactive than Br, so the answer is yes. So there is a reaction. Now, let me take another example. Look at this one here. D, can Br replace Cl? Can Br replace Cl? No, it cannot, because Br is less than reactive than Cl. So Br cannot replace it. And it's the same question over here. Br cannot replace Cl, but Cl can replace Br. Cl is more reactive than Br. You are probably wondering why I chose to check Br and Cl and not Br and Na. I cannot do a replacement of a metal and compare it to, of a non-metal and compare it to a metal. So here, Br is a non-metal. Br is a non-metal. Cl is a non-metal. Na is a metal. So if I'm going to check the replacement, I will see the non-metal if it can replaces a non-metal, or a metal, like for example in this case magnesium, if it can replace another metal. So magnesium and silver, let's see over here. Here's the magnesium over here, and here's the magnesium, and here's the silver. Magnesium is more reactive, so it can replace. So you'll write R, reaction. Now, silver will not replace a non-metal, the Cl. Here, the H is playing the role of a positive ion, H+. So we need to check if silver can replace the H in HCl. And it cannot replace the H in HCl because H is more reactive. So this one, no reaction. Now, finally, the last question, can magnesium replace H in HCl? Here's magnesium, and here's H in HCl. So magnesium is higher, so the answer is yes, there is a reaction. Let's move on with our practice sheet. The second topic, second subtopic in topic 5, the reaction in aqueous solutions. And here you have to be careful when you are looking at double displacement reactions. Always rely on the physical states written over here. So it's always an aqueous compound added to another aqueous compound. You need to check if when we switch the first metals together, look, the Cu and the Na replaced each other. Now it's the Cu coming with the OH and the Na coming with the Cl. So you need to look at the product formed. If the product formed is aqueous, then whatever that constitutes this aqueous, like Na positive and Cl minus, these will be called spectator ions because they were aqueous. Na was aqueous. Look at this one here and focus with me. Na was aqueous, Na still aqueous. Cl was aqueous and Cl still aqueous. Whereas I'll change the color, OH was aqueous, and now OH is forming part of the solid compound. And copper was aqueous, and now copper is part of a solid precipitate. So the ions that remain that retain their physical state, aqueous, are called the spectator ions, whereas the other ions, the Cu2 plus and the OH minus, are not spectator ions. Not spectator ions. These are the ions that participates in the net ionic equation. So they participate in the net ionic equation. Now in this question, they are looking for the spectator ions. So you need to look at the ions that they had a physical state of AQ and still AQ. So the answer is A. Another question here. Look at this one. PB was aqueous. Now PB is part of a solid compound. So PB is not a spectator ion. Pb2 plus makes part of the net ionic equation. Now let's look at the other one. NO3 was aqueous and NO3 still aqueous. So NO3 minus is a spectator ion. No change to it. Now, let's take K. K was aqueous. K still aqueous after they did the replacement. So K plus also is a spectator ion. Whereas I was aqueous and now I makes part of a solid compound. So I minus is not a spectator. The ions that contribute to the formation of the solid product are the ions that participates in the net ionic equation. And the net ionic equation here will be between these two ions forming the solid precipitate. So the answer is A. And of course, the spectator ions, as mentioned, are K plus and NO3 minus. The key to solve properly these questions is to compare what happened before and what happened after the reaction. Moving on, again, another question. To write the complete ionic equation. Since this is written in the focused question, so I cannot underestimate these questions, and you need to split. When they ask you, write the complete ionic equation, you need to show the ions of every compound. Now, in your formula sheet, you have the list of ions given to you, the list of polyatomic ions, and this is going to help you. Like, for example, in this question, I have AgNO3. So here's the NO3. NO3 is negative. The rest of the ions, you can find them in the periodic table. So, like an Ag and NO3, I can split this into two ions. An A belongs to group 1, so it's a positive 1. Cl belongs to group 17, negative 1. Again, an A plus. Here, once you know the ions will not change. So, in the complete ionic equation, that's what I'm going to write. So, Ag plus, I will split and show the ions of every single compound, plus NO3 minus, don't forget to put those physical states in brackets, plus Na plus and Cl minus. I can see that anything ionic, you will keep on writing it in the ionic form, like Na plus and NO3 minus, but whatever that forms a solid precipitate, you are not allowed to write it in form of ions. So this solid will be written as it is, no ions to show. And therefore, when they ask you to write the net ionic equation, you select the ions that form this compound. So the net ionic, you will only choose the ions that contributed to the formation of a solid precipitate, and they are Ag and Cl minus. So we write here Ag plus aqueous, Cl minus aqueous, giving AgCl solid. This will be the net ionic equation. Be careful to these kind of questions. Now, in this chemical equation, which of the components is a precipitate? It means which of those will form a solid. Now, we just solved this question here, and I know that AgCl is the solid, but I want to explain to you how can you get this from the formula sheet. So, if you open on the solubility rules, here the compound that we are checking is AgCl. You need to look for Ag and Cl. Like for example, here it says, here's chloride ion, usually is soluble. And when we say soluble, we mean by it AQ. But there is an exception. When Cl pair with silver, which is our case, or lead, not our case, the resulting compound are insoluble, means solid. Okay, so in this case, AgCl is the solid precipitate we are looking for. This one is going to remain aqueous. This will be solid. Now, moving on with the questions. A student carried out an experiment where he mixed solutions of sodium hydroxide, NaOH, and HCl. Please focus a lot on these kind of questions. So, write the balanced chemical equation with the state symbol, and you have to indicate the AQ and the solid or liquid or gas in it. And then you have to write the complete ionic equation and then the net ionic equation. So, whenever they give you questions like this, I advise you to start with the balanced chemical equation and to replace the places of the ions. So, I have here an NaOH, it's always aqueous, plus HCl, aqueous. What you're going to do, you are going to take the sodium and replace it with the hydrogen. So that makes it HOH, which is known as H2O. So I can simply write H2O in this case. Plus, here, the other option is the Na now, since it was replaced by H, Na is going to take the place of H and become with the Cl. Now they want the state symbol. And here, H2O, we know very well that H2O is liquid. Memorize that one. And NaCl, we need to check the solubility rules. And according to the solubility rules, any compound with Na, without any exceptions, with no exceptions whatsoever, these compounds are always soluble. So in this case, this is AQ. And now I am able to write the complete ionic equation and even the net ionic equation. The net ionic equation, you only take the ions that contributed to the formation of the liquid or solid or gas product. So, and in here, it is the H coupled with the OH. It is H plus coupled with OH minus 1. Aqueous and aqueous who contributed in the formation of H2O liquid. Now, when they ask you to write the complete ionic equation, it means you have to split the ions of every compound and separate them. And A belongs to group 1, so it is positive 1. And OH, in case you forgot, here is the OH minus. I told you you have always this list of polyatomic ions. Please use it. See, it's OH minus. So aqueous plus H plus and Cl minus. The result in the formation, this results in the formation of H2L liquid and Na plus and Cl minus, both of them aqueous. The aqueous, you always have to write them and show the ions whenever they ask you for it. And now we are going to move to the next topic, topic 6. Definitions of molar mass, moles, and atomicity. What is the definition of a molar mass? Molar mass, the one that we calculated from the periodic table. And the unit is always how many grams per mole. So it's the mass, not a number, we're not counting. So it's a mass of 1 mole, gram per mole of a substance, and expressed in grams per mole. So here's the answer. Atomicity. Atomicity, it refers to how much atoms I have in a molecule. Like for example, if I have H2O, the atomicity here is 2 for hydrogen, 1 for oxygen. Or C6H12O6, atomicity of carbon is 6. Atomicity of hydrogen is 12. It means that I have 12 atoms of hydrogen in this compound, and atomicity of oxygen is 6. So atomicity represents how much atoms in a molecule of a compound. Now, calculate the number of atoms in an element or a compound and vice versa. So here you are given this formula, these two formulas to use. They did not give you the formula. Oh, okay. So we only have how to calculate the mole, which is mass over molar mass. The other formulas are not given, so it means you need to memorize this formula. Mole is equal to the number of particles, and the particles could be atoms, molecules, or even formula unit, divided by Avogadro's number. This is the mole. The formula where we have atomicity is not to be found in this question, is not yet, because they are asking how many atoms in 1 mole of an element. So if I have 1 mole, how many molecules or how many atoms, how many representative particles we have? So here, Avogadro's number, 10 to the power 23. And to find how many atoms, it's again Avogadro's number, 1 times 6 times 10 to the power 23. Moving on, how many water molecules? They are asking about the molecules in 0.5 moles. So the moles is equal to the number of particles. Particles again could be, I'm going to write it here. The particles could be molecules, could be atoms, could be ions, could be formula unit. Except that here in this question, they are asking for the molecules. So the number of molecules in 0.5 moles, how much is it? So here's the formula, 0.5, this is X, and 6.0 times 10 to the power 23. So the answer is 3. C. So it's a 3 times 10 to the power 23. Moving on, in the chemical formula, C6H12O6, what does the subscript 6 for carbon indicates? This 6 means that in this formula I have 6 atoms of specifically carbon. So the number of carbon atoms in this compound are 6. In the compound of CaCl2, what is the ratio of calcium to chlorine atoms? It is 1 towards 2. So it is 1 to 2. For example, if I have an A3P, the ratio here is 3 to 1. Now, calculate the number of moles of hydrogen and oxygen in 18 mole of H2O. You have to read carefully the question. They don't want the number of atoms of hydrogen. They want the number of moles of hydrogen and moles of oxygen. So moles of hydrogen and moles of oxygen. Again, we look at this formula. It is the number of mole, memorize this. It's the number of mole of the compound times the atomicity. Or you simply look at H2O and you say, in one H2O, we have 2 hydrogens and 1 oxygen moles. Then in not just 1, in 18, how much you have. So in this case, or maybe I'll write it in this way. In 1 mole of H2O, I have 2 mole H's, but I also have 1 mole of oxygen. Now, if you give me 18 mole of H2O, that's going to get me X mole of H or Y mole of oxygen. So how do I find X? It's 18 times 2. So here in this case, the number of moles of hydrogen is 18 multiplied by the atomicity of hydrogen, 2. That's 36 moles of hydrogen. And for oxygen, it's 18 multiplied by the atomicity of oxygen, which is 1. So 18 mole of oxygen. These formulas to memorize because they are not given in your exam. Now next, what is the mass of 2.5 mole and ACl? I always tell you in class, whenever they combine mass and mole, there's one formula to use, which is mass over molar mass. Mole is equal to mass over molar mass. Using the periodic table, you get the molar mass, but here in this question, they already gave it to you. So you simply substitute 2.5 equals mass over molar mass. Always, always, always write your answer with the unit. So the mass here would be 146.1 gram. Don't forget the unit of mass or else you will lose marks. Now again, how many molecules are there in 9 grams of H2O? As I mentioned, whenever you have mass, immediately think about mole equal mass over molar mass. So first, let's find the mole. So the mole of H2O is equal to the mass of H2O divided by the molar mass. Now, what's the molar mass of H2O? This is something you have it in the periodic table. Molar mass of H2O is twice the molar mass of hydrogen plus the molar mass of oxygen. These molar masses are the larger numbers given in the periodic table. So it's 2 times 1 plus 16 equal 18 gram per mole. So here I will substitute with the 18 gram per mole and the final answer is 0.5 mole H2. Now, I found the mole. What do I need? Now I need to answer the question. They want to know how many molecule. Again, this mole, it is true that this mole is equal to mass over molar mass, but also this same mole is equal to the number of particles, and molecule is a particle, divided by Avogadro's number. So knowing that the mole is 0.5, I'm going to substitute and calculate the number of molecules. So the answer would be 3 times 10 to the power 23 molecules of H2O. Moving on. How many moles contain the given quantity below? So again, they are giving you to calculate the moles of a given quantity, and the quantity is a molecule. It's a representative particle. So please remember this formula: particles over Avogadro's number. So I do have the number of molecules, which is 1.2 times 10 to the power of 15. We will divide this by Avogadro's number to get the mole that we need. So the answer here is going to be 2 times 10 to the power negative 9 moles, sorry. Now, how many mole I have in a mass? Again, as I told you, in order to find the mole in a mass, you need to divide by the molar mass. But here you need to find molar mass first. So let's spread this. In this one I have 3 carbons, need to get their mass, with 6 hydrogens, and I have the OH twice. So the molar mass is going to be, I'm going to find the molar mass over here. It is 3 times the molar mass of carbon, which is 12, plus 6 times the molar mass of hydrogen, plus 16 plus 1, again 16 plus 1. And the molar mass is 76 gram per mole. So here I'm going to write this given mass, the 38 over 76 gram per mole, and the answer is 0.50 mole. So please be careful to the formula that you are using. To convert from mole to mass, here's your formula. To count atoms, molecules, particles, here is your formula. It's always done through N. Number of particles over Avogadro's number. Now, interpret the following balanced equation in terms of moles and mass. When they tell you in terms of moles, you only need to read this equation given to you in form of a sentence. So you will say 1 mole of K2S, you don't have to know the name, reacts with 1 mole of COCl2 to give, to produce, to form, to yield, you can say whatever you want, 2 mole of KCl and 1 mole of COS. There you go. Now, in terms of mass, you need to focus on the mole that you just found and multiply it by the molar mass. So like 1 mole, I need to multiply it by the molar mass of K2S to find the mass. And 1 mole of cobalt, you need to multiply it by the molar mass of cobalt to get the mass. And 2 moles of KCl by the molar mass of KCl, and 1 mole by the molar mass of COS. So in this one, we are always applying the formula that in order to find the mass, we need to multiply the mole by the molar mass. So here this is a bit long question. So you need to find the molar mass of all of them. The molar mass of K2S is the molar mass of K times 2 and the molar mass of S, and that is equal to 110 gram per mole. So I would say 110 multiplied by 1, it's 110 gram K2S. Again, reacts with, again I have 1 mole, so I'm gonna put here 1 mole, and at this time I'm going to multiply by the molar mass of cobalt chloride. And the molar mass of cobalt chloride is the molar mass of cobalt plus twice times the molar mass of Cl. And the answer is 130 gram per mole. So this 110 gram of K2S is going to react with 130 grams of cobalt chloride. I copy the sentence to give now 2 moles of KCl. So I'm gonna multiply the 2 by the molar mass of KCl. And the molar mass of KCl is the molar mass of K plus the molar mass of Cl, and that is 100. Okay, so I'm gonna get you the mass of potassium, of KCl, and it is 75.5 grams, 74.5. So we're gonna multiply this 74 by 2 and write the answer, and 1 mole of COCS, again 1 times the molar mass of COCS, which is 91 grams of COCS. You have plenty of exercises also in Classic about this. Now show that the law of conservation of mass is observed in the reaction. So in this case, you take the given masses and you check if they are, or you show that they are equal to the masses after the arrow. So here I have 110 gram plus 130 grams. Then I need to check if it is equal to 2 times 74.5, that's 149 grams and 91 grams of COS. So plugging this into our calculator, we find that really they are equal. So we say that the law of conservation of mass is observed. Mass of reactant is still equal to the mass of products. Now, interpret in terms of representative particles. When they say representative particles, you cannot say 2 mole, 1 mole, 2 mole. You have to say the type of this particle. So an A coming alone like this, like that, is an atom. So 2 atoms of an A reacts with 1. Cl2 is not an atom, Cl2 is a molecule. Any covalent compound, you can call it a molecule in the representative particle. So you call it a molecule. So react with 1 molecule of Cl2 to produce 2 ionic compound of NaCl. 2. Now ionic compound, you will call it not a molecule, instead you will name it as a formula unit. 2 formula units of NaCl. Now, moving on to the questions involving mole ratio. From where are the mole ratios derived? in chemical reaction. We always write the mole ratio by using the numbers written on the equation. Like for example here, 2, 1, and 2 are used to write mole ratios. So we write the mole ratios from the coefficients in a balanced chemical equation. For the reaction N2 plus 3H2 giving 2NH3, what is the correct mole ratio of N2 to H2? So it's 1 to 3. It is C. Moving on. Write a balanced chemical equation for the following word equation. Here you have to write the equation and then balance it. So you read carefully what is given to you. 1 mole, they will give you simple formulas that you already studied in term 1 and are the simple ones. Like 1 mole of solid magnesium. So from the periodic table, magnesium is a metal Mg solid. And they're telling you just 1. Reacts, so it's a plus. Reacts with what? With 1 mole. Mole of what? Chlorine. Chlorine is written as Cl2. In the periodic table, there are only 7 molecules that takes number 2 next to them. And they are hydrogen. Whenever they tell you hydrogen, you see H2, never H. Oxygen, nitrogen, and then the elements in group 17. All of them like Fr2, Cl2, Br2, and I2. So magnesium reacts with 1 mole of chlorine gas to produce. So when they say to produce, you put the arrow. To produce what? To produce 1 mole of solid magnesium chloride MgCl2. When they ask you these questions, look for the physical states. We always deduct mark if the student did not put the physical state. So here they told us that chlorine is a gas and MgCl2 is a solid. Now determine the possible mole ratio of the reaction above. And in order to know the mole ratio, how many mole ratio, we count the components of this equation. Like for example, I have 1, 2, and 3 different substances. Since I have 3 different substances, I will apply the formula of N times N minus 1. So 3 times 3 minus 1. That is 3 times 2. That is 6 mole ratios. So we are able to write 6 mole ratios. And here's the answer. Now again, given the word equation, it's a word equation written in words. 2 moles of hydrogen gas H2. So we're talking about 2 H2 gas reacts with what? With 1 mole of oxygen gas O2. So 1 O2 gas to produce 2 moles of water vapor. And when they tell you here water vapor, we are talking about H2O vapor gas, not liquid. So which of the following is the correctly balanced equation? By reading carefully the question, the answer is B. Now, calculations. Be careful to these questions of calculations. Watch all the recorded videos, tutorials that I have left for you for the end of term exam. It says 6 moles of H2 are used. How many moles of H2 are needed? So the deal is between N2 and H2. We start using the given 0.60 mole N2 times. Always the second step, when you take the given u and it's small, you immediately multiply it by the mole ratio. And in the denominator, you write mole of N2 so that you can cancel N2 on both sides, and up you write the mole of what you desired, the molecule desired. And then you get the mole ratio from the equation. Next to H2, there's 3. Next to N2, it's empty, it means 1. So the final answer is how many moles of H2? So it's going to be it's a multiple choice question, 1.8 moles. Moving again, how many grams of NH3 are needed if I have 0.2 moles of N2? So I always start with the given 0.60 mole N2. Immediately down here, mole DM2. And what do I want to find? I want to find the grams of NH3. So first, I'm gonna put the mole ratio of NH3. So let's find this one out. It is 2 and 1. So the answer over here is 1.2 mole NH3. And now the question is clear. How many grams of this mole? So we use the formula of mass over molar mass. So 1.2 equal mass, and the molar mass of NH3 is the molar mass of N plus 3 hydrogens. So it is 17. We continue. Calculate the mass of CaC2 needed to react with 3.6 grams of H2O. Be careful to these questions. This is mass to mass. If you remember on the map that I gave you in class, whenever I have a mass, I always have to divide it by the molar mass. And if I want to find a mass, I have to multiply. So let's first convert the given mass into given mole. So mole equal mass over molar mass. So 3.6 mass of H2O divided by the molar mass of H2O. And the molar mass of H2O is 2 hydrogens and 1 oxygen. That is 18 gram per mole. So the final answer now, the first answer is 0.2 mole of H2O. So now how many grams of CaC2 we have from 0.2 mole H2O? So you take this to 0.2 mole of H2O and you multiply it by the mole ratio. So again, H2O is down in here, mole of CaC2 are up in there. So I have CaC2 is 1 and H2O is 2. So the answer is 0.1 mole of CaC2. But does the question just want mole or the question want mass? It wants mass. So the last step, mole equal mass over molar mass. Here's the mole, here's the mass, and the molar mass is the molar mass of calcium plus the molar mass of carbon twice. And that is 64 gram per mole. So the final answer is 6.4 gram. Moving on with this question. Limiting and excess. Be careful to these questions. Why does a reaction between two substances stop? Probably because one of the substances finished. It is completely used up. So when the reactants are equal, are used up, preventing further reaction. So خلاص, it stopped. What is the limiting in a chemical reaction? The limiting in the chemical reaction, it's the compound, the reactant that is first finished, first used up. And it's because it's used up and finished, the reaction had to stop. So the answer is B. The reactant that is completely used up first. Now, next. What if a diagram is given to you and you need to find how many limiting and excess? And in this case, all I can tell you is count and count and count. I have 1, 2, 3, 4, 5, and 6. 6 moles of H2. So here we have 6 moles of H2. And I have over here, and this one, 1, 2, 3, 4, 5 of O2. However, if I look at the diagram over here, I'll find that oxygen still forming next to the products. You see? So oxygen is not finished. So this is the one that is excess, and hydrogen is the one that in limited quantity. So the answer is C. So I'm going to continue. We continue with the question, and the next one now is how many moles of the excess remains. You can simply look at the diagram and you can see that I have only 2 O2 remaining. So the answer is B. My pen is not working, so I'll try to continue here. If 3 moles of HCl are used up in the reaction below, how many moles of FeCl3 are produced? This is a mole to mole calculations. So you're gonna take this 3 moles of HCl and you're gonna multiply it by, so moles of HCl, you're gonna multiply it by the mole ratio in order to find how many moles of FeCl3 is formed. So 3 multiplied by 2 over 6. So the mole ratio between HCl and FeCl3 is 2 over 6. So 2 over 6. And the final answer is B. And that's it. Good luck in your exam. Hopefully you'll get the mark that you want.